So what are the social sciences? We take in the book a very broad brush view of what the discipline group includes. And you can see here that everything in the orange box is a social science, but there are some significant areas of overlap with STEM disciplines here and with humanities disciplines over there. And to some degree, people differentiate themselves inside these disciplines by how much they aspire to be scientific in the humanities crossover area and by how much they study physical or natural type systems in the crossover area with the STEM disciplines. So this group of disciplines taken as a whole is a very large and substantial group. It contributes a great deal to the overall development of our civilization. The biggest group in the area is one of the most difficult to study, which is academic studies of education. And I've given this talk now to a couple of departments of education, and they all point out in an aggrieved way that actually this is the only figure in the book where education features. So this is a bit of a mistake. But then you can see the rest of the disciplines in terms of how many people are working in them, how many academics there are, with the sort of classics up here, the overlap areas with STEM here, and the biggest of those, of course, is social psychology, and the overlap areas with the humanities. Now, we have a particular methodology in the book for estimating how big that overlap area is. It varies from discipline to discipline. Social sciences are also unique in the extent to which what they do is mediated by other organizations into a very wide range of different contexts. And so there are really, we could think about inside each discipline there are these four areas that come from Boyer. So discovery is a sort of classic scientific discovery, integration is putting things together, application is applying things, renewal is really teaching and renewing the profession. Those are very important. The social sciences also have a very strongly developed sense of joined up scholarship, much better developed in some ways than other discipline groups, and there are particularly three big contributors here: bridging intellectuals, the integration at university level, which is a very strong and powerful force, and academic service by academics in government and professional contexts. And then we have all these different intermediary organizations, including media, professions, think tanks, consultancies, policy organizations, and increasingly NGOs, who translate and reaggregate and repackage and resell often these ideas to government, to business, to the media, and to civil society. So this is a very important set of disciplines for us collectively understanding what it is that we're doing and how we do it in lots of different contexts. Now, just to give you a sense of the scale of those mediation, we can start with the research core in social science and think about it in terms of two elements: the number of people who are involved, the people value, and the economic value, which derives, I should say, from some work that was commissioned by our project from Cambridge Econometrics. So in research core terms, we've got 32,000 academics, staff, who are active in research terms. And into the social sciences, we get about £850 million worth of funding. Now that's a very important part of an overall wider activity by the discipline group. So there are another 3,000 academics who are teaching only, so it doesn't go up more, and this partly because only 1 in 10 social science academics is research only, compared to 35% in physical sciences. And the amount of spending goes up a little bit to 2.7 billion. Needless to say, these boxes are not to scale. Then we think about, well, what's the add-on value? And in people terms, we can measure it in terms of the number of students, 625,000 students on our definition for the social sciences. And then we could also think about, well, what's the economic value of this spending that the social sciences are doing? What's the indirect and induced economic value? And that pushes it up to 4.8 billion. And then finally, we could think about the mediation. Now, this is the most difficult thing to measure, but it is possible using the labour force survey to get an idea of how many people are working as social science professionals in other organisations. And if we do that, we come to about 410,000 people. And these are people with doctorates or with master's degrees in the social sciences and with job titles that are indicative of professional activity relevant to their degree, and with social science degrees, obviously. So we have about 410,000 people doing jobs that rely on social science, and there are two big areas. One is government and the public sector, and one is banking and financial services. And a third area is in consultancy and so forth. And if we look at what these external organizations pay these 410,000 people to do these jobs, we get a measure of what the external value of the social sciences is, and that crunches out at about 25 billion pounds a year, of which 10 billion is in government, 10 is roughly in financial services and banking, and the rest is in consultancy and assorted other things. So that gives you an idea of a portrait, really, of the discipline group that we cover and discuss in the book. And the book has very detailed and extensive discussions of how social scientists work with government, with business, with NGOs, with the media and civil society. Now, towards the end of the book, we tried to theorize this in some kind of way that would help us to picture it better. And we came up with the concept of a knowledge inventory, and then we explained this to a few people. And in some context, some business person said to us, "You don't want to have inventory because inventory is on sold goods." And he did say this in a very Yorkshire accent. "It's just a lot of old junk sitting in your warehouse that nobody ever uses. It's good for nothing."
Is that meant to be a northern accent?
Yeah. I was born in Halifax, so I should know. So then we added dynamic at the front so as to stop people saying bad things about inventories. But a knowledge inventory is dynamic, and it is a very different kind of inventory from, you know, an old PC rusting away in a warehouse. In particular, the knowledge that we have in use is a relatively narrow band that sits on top of a lot of knowledge that we have that we're not currently using. And it sits on top of it in a slightly fragile way. If a crack opens up here, or a hole opens up here, a hole will open up here as well. So it's very important to think about the relationship between the knowledge that you're using and the knowledge that you have but you're not using, or that you have but it's passive, or you have but it's in the background. And of course, as we move in more and more into a modernized society, we really have three different categories of knowledge. Ordinary knowledge, which is often looked down on by academics, but which I believe, following Lindblom and Cohen, is incredibly important. And this is knowledge that's expert, possibly, but it's not systematized or established via professional social inquiry. Then we have a lot of applied knowledge and research, and then we have theory-based abstract knowledge and research. So we need to think about the relative presence of these three things and how they interact, and in particular, how the transfers take place across the boundary between what's used and not used, and between what's applied and not applied, and what's theoretically known and not theoretically known. And the book really traces a pretty detailed picture of how that process operates. So that brings me to the second part of my talk, the bit where you get lots of flashing photographs. And the question here is, well, what does the social sciences as a discipline group, what do they focus on? We've had various kinds of answers about that before, and many of these answers are embedded in the terminologies we have, the conventional frameworks we have for thinking about this. And what I'm going to do is propose that previous frameworks haven't been terribly useful, and that we can reconceptualize in a way that's helpful. So let me try and make that case. Well, the traditional polarities, and sadly still Western intellectual thought is still overly governed perhaps by polarities and dichotomies, but the traditional ones have been between the physical and human sciences. What's the problem there? Well, the problem is pretty obvious, that many of the physical sciences are studying human beings, and that doesn't make any kind of sense. Is medicine a physical science or is it a human science, for example? So that just looks like a non-starter. Between natural and human sciences, well, when people talk about the physical sciences as natural, that raises some issues that were addressed in a book by Herbert Simon, where he discussed natural versus artificial sciences. And he says, natural science is a body of knowledge about some class of things, objects, or phenomena in the world, about the characteristics and the properties that they have, about how they behave and interact with each other. Natural phenomena have an air of necessity about them in their subservience to natural law. They are as is. And the interesting thing there is that the contrast between natural and artificial phenomena being defined as designed, made, intended artifacts, and so on. So the problem about natural and human sciences is that a great many of the sciences are actually not natural. Their focus is not natural. Their focus is, in many ways, completely artificial, more artificial in many ways than the focus of social sciences. So that doesn't help at all. And then the other great standby, particularly of STEM scientists who don't like social science, still quite a few of them around, is the idea that they're doing normal science and everybody else is doing non-science. And that is a sort of a powerful ideology, but it's increasingly challenged by the concept of post-normal science, which points out that actually when you move away from genuinely physical, genuinely natural phenomena, when you move into applied areas, you move into a sphere of much more contingent knowledge than you had before. So the idea that there's a sort of unchanging normal science, which sadly a great many economists are still trying to contribute to, is slightly old-fashioned really as an idea. And that's why actually, if you look at most contemporary discourse, people contrast STEM disciplines, which just stands for science, technology, engineering, and mathematics. I always get the M wrong. I keep thinking it's medicine, but it's mathematics. Versus social science. And that's just a descriptive label. It doesn't have any of the kind of focus elements that these earlier concepts had. And I think that's important too because of Simon's discussion of natural and artificial systems, which I think is a very interesting and potent one, and which had a very big impact in its day and created the whole push for design science. So, you know, his ideal is much more about a practical science that makes it possible to improve and to correct extra scientific praxis. And actually what that meant in practice was a set of fields, particularly concentrated on what he regarded as artificial areas. And they certainly do have a certain degree of resonance, but I don't really see, this has been going since the mid-1960s as a concept, and I don't really see that it's made the kind of coherent, connected development that perhaps he argued for. So when we're thinking about this alternative framework, there are three concepts to think about. One is human-dominated systems, one is human-influence systems, and the question here is, how great is the extent of human structuring, of purposeful structuring of the system that you're looking at? That's really the distinction here. And human-dominated systems are pretty well wholly designed, and they may not operate as they're supposed to be designed to do, but they are designed artifacts. And human influence systems are not. But human influence systems are combined systems, really. And we need to distinguish them from natural systems that are operating without human intervention. So this is where I'm going to show you some photos. Human-dominated systems comes from ecology, where the concept of human-dominated ecosystems refers to things like this farming landscape. I hope you guys can see this okay. I don't know, is there any way we could turn off the front row of the lights? This might just help. So we have a very regimented, very organized kind of landscape and a very organized set of ecosystems, which I think is an interesting literature in itself. And then we have things like what the LSE research group calls in one of their books rather graphically the endless city, and where I think this Jackson Brown quote is very helpful. You know, 1 foot on the concrete shore, 1 foot in the human sea. It's a sort of a socio-technical system of rather depressing extent. And when we get up close, we can see the people, and we can see that the way in which people behave, the way in which they operate in these different settings, has a great influence on the overall vibe, the overall look and feel and characteristics of perhaps similar settings in some sense. So we can see the importance of the human bit at this scale, but if we step back, we can begin to think about this as much more of a physical kind of set of phenomena, or a designed physical system. Now that looks like you know, it looks very physical at this scale, at this distance, in this light, and so on. But if we were to do something that influenced the information available to these drivers, we might rapidly see a complete change of behaviors just from inputting information into the system. And then we have manufacturing and economic processes that look a long way from human intervention and are increasingly perhaps becoming robotic. Some estimates suggest up to 50% of jobs in the USA may be automated in the next 10 to 15 years. And of course we have some wholly automatic elements of the economy and the information systems that we're using. This is a picture of a Google server farm, of which there are hundreds across the world now, consuming a vast proportion of our electricity generation. And of course there's nobody inside. And all of this is expressed to us and fed back to us via interfaces as numbers, very detailed numbers in markets. That looks baffling and tricky to control. But even when we simplify it into, you know, really simple economic graphs, we get a picture that's pretty out of control and hard to predict and changeable and so on. So the way in which we understand what our civilization is doing has changed. It's become more and more organized. It's become more and more a technology of organizations. And the interesting features of early information processing Anybody spot the supervisor here? And then we have a more complicated politics, and we have a more complicated media system that allows us to process all this stuff. And we still have anthropologically necessary functions that we're trying to carry out, which looking after the sick and the aged is obviously increasingly dominant in terms of likely to eat all other bits of the state in the next 20 to 50 years, but also educating the young and so on. And we can now begin to look at social networks in very much more stylized ways than we could before and think about how they operate. But we always need to put them back into a context which is a bafflingly complex context, and where the human element is incredibly important. So those are human-dominated systems. Now that's a big terrain. And if we think about what that means in terms of who should the social sciences be talking to amongst the STEM disciplines, it's a big list. It includes the whole of medicine, health studies, psychology. It includes the whole of engineering, information technology, computer science, informatics. Increasingly, software development is very important in the development of social science knowledge. And of course, we've got all these things to do with cities and with understanding our own very complex and speeding up, possibly, history. So these are very substantial areas of overlap between the social sciences and the STEM sciences, and their focus is that they're all, in one way or another, seeking to understand, control, influence, shape, and improve these vast and extensive human-dominated systems. So there's a huge common cause, and this is one thing that makes me pessimistic about the LSE, because we don't have any of these disciplines where I work at the moment. But other universities do, and that's really a powerful and important area for development. So that's the human-dominated systems bit, and the social sciences are a big part of human-dominated systems, but they're also a big part of human influence systems, and we chose a little tree symbol here just to try and show a bit of the difference. Well, what is the difference? Well, we also have another concept in ecology called human-influenced ecosystems. And I think virtually, sad to say, but true, virtually all parts of the planet now are human-influenced in one way or another. There is no physical frontier that's unexplored or unpopulated. And even, for example, if we're looking at this bluebell wood, that's a pretty artificial creation. Somebody had to go in there and chop down all the undergrowth for the bluebells to flourish. Because when we see natural movements occurring on very large scales, I'm a big fan of, David Attenborough type documentaries, we can think, well, wow, that's a natural system, and we can look at things like flocking and herding and migratory behaviors and marvel at the scale and intensity of what's involved here. But sad to say, most of these are in one way or another being influenced by human development. And we can see human influence systems very strongly when we think about those things that go wrong, where we've tried to organize the water into some places and it turns up in other places. And there are some systems we can't influence at all, of which geophysical and earthquake type systems are the main component on the Earth. We can see the consequences when they conflict with human settlements and development. But of course the whole climate change debate is a debate about humanity influencing very, very large-scale global systems. So we might say if this is true, which I for one am pretty convinced that it is, obviously we've tended to focus on the implications, cute penguins left on dwindling ice flows, but the interesting thing is, are there any purely natural systems left in the world now or not? And if not, which is what I believe, what are the key areas of disciplines in the STEM group that we should be collaborating with? And again, we have this list would be my list. It's not as big as the human-dominated systems, but it's interesting that there are already overlap areas extending into social science here as well. And that finally leaves us with natural systems. And where are these natural systems? Apart from the geophysical bit, I'd say they're all off-planet. So, astrophysics, pure maths, there's some asocial systems, but everything planet-wide, almost, is about human-dominated or human-influenced systems. So this is a big agenda, and it's a shared agenda, of course, with the STEM sciences. Now, gets me onto my third part of the talk, which is what condition are we in for tackling this agenda? And as I say, I'm very hopeful. But let's start with the reasons for skepticism, and there are plentiful reasons around, most of which you've probably heard rehearsed dozens and dozens of times, which doesn't mean that you can't rehearse them back at me, but yeah. So it starts with the strength and fundamental importance of disciplines, the extent of siloing, the unlikelihood of people being able to break out of that, the difficulty of starting off as a PhD and then being a young academic and then being promoted and then publishing in journals, and then the iniquities of the old research assessment exercise, which of course was incredibly siloed, and generally of peer review processes. All of these are extremely conservative, restrictive, and tending to mitigate against connectivity of intellectual activity. And there's also a pretty consistent and constant reductionist push in the development of new fields of activity. And you can see this quite well in a recent paper by Christakis, where a blog really, where he argued that we should close down the traditional areas of social science like the sociology of inequality, leave a small palace guard to guide the echoing ruins, and transfer everything in all our resources into new fields like neuroeconomics and very, very detailed reductionist fields. So there's a constant pressure there, which it would be folly to ignore, partly because of American funding systems still being very powerful in this area. And of course, new countries, new research powers like China also having very strong reductionist push. And we have all the general difficulties of people in different disciplines talking to each other, the difficulties of conflicting values, differing methods, differing criteria of what counts as truth, differing criteria of what counts as evidence, differing measurement concepts, all of which have been quite extensively researched. And then finally we have the literature on implicit knowledge and explicit knowledge. If it's very difficult for one team in one lab to understand how another team in another lab has done a well-documented experiment, if they usually need to actually visit and actually see exactly how it was done to get to grips with it, how on earth are we ever going to combat the differences between disciplines, let alone between whole big discipline groups like the social sciences as a whole and STEM disciplines as a whole? So this is a big agenda of, reasons to be not cheerful, but I think we can think about how far actually we've come. So we've moved a long way from the days of single academic silos conducted just within universities with a little bit of remote, I can do this bit but I can't do anything more kind of consultancy. That's a paradigm that's still there, and particularly amongst older people I guess it's still there. But we've had within universities a big push towards more topic-linked work, in multidisciplinary work, so joined up topics. You've only got to look through, let's say, STEM scientists writing about mitigation of climate change to realize there's a huge amount of joined up topic-linked work which spills into social sciences. And then really joined up work with people making a serious effort to get to grips with the other person's perspective, the other person's values, the other person's way of doing things, has also greatly increased. I'm not saying it's wonderful, but it's certainly impressive. And similarly, we've had a huge seepage of research out of just universities and into other organizations, into professions, into professional consultancies, into big corporations, and so on. So a huge volume of R&D is now being undertaken outside universities. And that firstly produces more applied research and much broader consultancy, because you can see it in our book. The one thing you have to be if you're going to have external impact is you have to be willing to say, well, I don't really know. My knowledge only goes up to here, and then beyond that, I'm just a sort of giving you wise counsel. But what I would suggest is, if you just stop at the limit and say, well, I'm sorry, that's all we economists can tell you about. After that, you're into the realm of psychology. You know, that's not very helpful, really. Virtually every business or government problem is a joined-up problem. So we've also had a growth of bureaucratically coordinated team research, very strong in IT industry at the moment, and with companies like Google going out and solving really big problems. So much so that we can now speak of the arrival of what's called transdisciplinary research, which is so integrated it doesn't make sense to even think about it as being a mix or a melding of disciplines. It's transdisciplinary, and there's very interesting documentation in our book about the extent to which that has involved, for example, IT companies bringing in social scientists into previously solely techno areas of activity. So I think we just need to recognize that the world, especially outside universities, has moved on from single discipline work. Single discipline is still a foundation, and a very important foundation, but it's not the be-all and end-all of academic work anymore. And of course we've had external pressure, rather formulaic, from research councils who've been committed to interdisciplinarity for a long time and then send it all out to very conventional peer reviewers. But, you know, I think the reprioritization of applied work in the REF impact cases element, that's 20% of funding, is a big start towards making applied work much more prestigious and much more self-sustaining financially than it has been in the past. We've had a massive development inside the STEM sciences themselves of science communication, which has really shot ahead, and compared to which most social science communication is terrifically poor. And I think if you look at, let's say, the LSE's impact blog, I see Sierra Williams, who's the editor, sitting right there, you'll get a really good grip on how important this whole field of digital communications and impact-orientated communication has become, and how important it is in terms of facilitating cross-disciplinary understanding and communication as well. So it's not just for external audiences. And finally, we've got strong internal pushes by leading committed academics towards being more interdisciplinary, and by younger scholars towards being more interdisciplinary. And why does that happen? How does it work? Well, my picture of disciplines is like that. Every bit of a discipline has 3 bits in it. The middle bit is the well-established core bit. It's what we call the dead heart, because you need 2 or 3 million quid to do any work in this area because the scale is very big and the level of difficulty is very big. When you go out, you usually find the world is pretty much the same as it was last year, and we know what we knew yesterday, or things that were valid then are still valid now. You can do a little bit of replication work, you can do some infilling, you can incrementally advance knowledge. It's a really bad area to do your PhD in. No sensible person would do a PhD in this kind of zone. Doesn't stop people doing it, but they shouldn't. And then around the dead heart we have the zone of moderate advances, the sort of purple zone here. And this is an area where it's you know, much more intellectually lively. We haven't sorted out all the issues. We're not just doing replication work. People with good ideas and interesting new experiments and little wonky takes on things can do creative work very much more easily, and they do. There's one reason why the REF or the RAE keeps finding islands of advance outside big departments, is the big departments are doing boring replication work, and the people who haven't got the resources are forced to do more interesting creative work elsewhere. But the really funky things are all happening on the borders of disciplines. The really funky things, the intellectually interesting things, the things where ideas are moving are all on discipline boundaries. That's what I'd suggest. And that's a strong pull for committed, young, creative academics. That's why so many PhD people end up being co-supervised and doing unorthodox things and a little bit difficult compared with the conventional core. And I think that's a very great movement, and it's a very strong hope for the future, which is why I think we should fund a lot more PhDs and a lot fewer big research projects, even though I run a research project group. Yeah. Well, where does this leave us? The traditional contrast has been between the STEM sciences and the social sciences has been well summarized by Randall Collins in one of his very great articles, where he argues that the reason why the STEM sciences have been so successful since the late 19th century is because of 2 things. Firstly, a high degree of consensus on what knowledge is. We don't have, inside the walls of each discipline, we don't have people disputing fundamentally what is known and what's not known. At the edges we do, and that's where attention focuses, and that's where we have a pattern, or has been a pattern, of strong, rapid advances in knowledge. So that the social kudos, the thing that really counts in STEM sciences, is to be in the rapid advance area. And that also feeds back into why there's why there's more internal consensus. And by contrast, the social sciences have been seen as low consensus, people constantly tearing up the roots of the discipline in order to inspect them, which doesn't tend to help growth. Very stalled or glacially slow advances, or inconclusive knowledge gains. And that's why we see, I think, the highly skewed pattern of resources that we do see at the moment between the discipline groups. So STEM is getting a much larger proportion of government funding, research funding, than the social sciences, and we have a much larger group of research staff and more research students, vastly more research students, most of whom then have to go off into some other job, not in academia. So the question is, what can we say that might be changing here, and what are the bases for a new growth period in the social sciences? I'll just swiftly move ahead here through this last bit because I'm running out of time, to say that digital communication, digital scholarship are very important stimuli for the social sciences. Big data is important. The move towards more complexity research is important. And also, on a huge range of issues, we've got a whole set of new methods and inflows coming in from the STEM sciences, which I think will have a big impact in creating some pooling of methods. Let me just quickly run over a few of those. Well, a complex systems focus is one possible basis for bridging between social science and STEM. And if we look at this list of features, which I'm not going to go into, we can see a great many things here which all of us can recognize as identifiable and relevant to social processes. I'm not totally in favor of complexity because I think it tends to produce a sort of complexity chasing for its own sake and a mathematicization for its own sake. But I do think that moving towards a much more complex, much more rich way in which we theorize systems will be useful. I'll skip over the next slide. What about big data? Big data advances are very important now, but it's a very badly misused term. And I take this set from a recent blog by Rob Kitchen on the LSE Impact blog, where he says, you know, you've really got to have all of these features before I'm going to recognize it as big data. The things that are important here are, you know, with big data you have all the cases. You don't have a sample. You don't need to bother about inferring from a sample to a population. That's very important. You have very big volumes of data so you can get very detailed. You have high frequency data so you can produce very timely findings. You can, it's scalable, it's very fine resolution, it's very relational nature, it's temporally and spatially referenced, it's flexible, and it's uniquely indexable. So those are really, you have to have all of those things going at once before big data is really there. But I think, you know, great as it would be to have these, and you can get to those through textual analysis, through administrative data, and so on from business and government. Actually, there's still greater potential, really, in just merely large data. Data that's objective, data that's about behavior, data that is not reactive. And I think just generally the social sciences need to move away from an over-reliance on surveys and on reactive data. And you can still get to things that are all cases, which is very important. You can scrub all those significance tests that you learnt in your youth. You can get to very large N, even if it's not terabytes of data. You can get very good resolution. You can get very scalable properties, and it's timely, even if it's only medium velocity. So what kind of things are we thinking about here? Well, we have a current bid into the ESRC to just pull together all the election data for the UK. Now that's just all the data across all the elections, across all of the time period. And why haven't we done that before? That's the kind of you know, gap that's actually very, very interesting and where there's a big scope. Then we've got a lot of new methods coming in from the STEM sciences that I think are having a great impact on the social sciences. I think we'll move away from social science specific towards much more maths and physics based quantitative work in the next 10 years. Software engineering and IT ways of doing things will become much more important. So we'll have to sort of scrub all that SPSS data stuff and start thinking in terms of Python or something like that. We're going to need a lot more systematic review. It's beginning to spread in from health studies and have very good effects. Referencing practices in the social sciences is still, broadly speaking, lamentable. And we're going to have great new ways of handling text, qualitative evidence, and organizational analysis. So that's a very big concatenation of positive developments, all happening at the same time and all tending to push towards a pooling of methods and evidence criteria with STEM disciplines. That brings me to my last slide. It's always a mug's game to look forward, and I've made my fair share of really dodgy predictions in my time, so here's another one. The next decade will see 3 big changes in the social sciences. Firstly, we'll move towards moderate consensus inside disciplines. I think we're already moved towards that extensively. I think we'll have fewer methodology wars. We'll have fewer debates where everybody says, no, this whole stream of analysis is utterly without value and should be repudiated, and sort of pulling up the roots that kills the plant debate. I think we are going to enter into much more applied work, much faster work, much more timely work, much more cumulative. I think academic blogging is playing an absolutely critical role in that. Sad to say, we still have to fight this battle over and over again with benighted university administrators who don't recognize that digital scholarship has moved everything. But still, does that mean the death of the theorist? You know Chris Anderson's famous thing, that correlation is enough. We just need to know this works with that, or this affects that. We don't need to know why it does it. We just need to know that it does it. I think that's been quite extensively critiqued and repudiated. But I do think there will be a push away from prestige and kudos inside social science, sitting with sort of big thinkers, big picture drawers, integrationists, towards people doing more applied and empirical work. And finally, I think that 10 years from now, the social sciences will be much more internally unified. It is staggering the extent to which the social sciences at the moment are not internally unified and are, run by different disciplinary cliques in terrifically siloed and, short-sighted ways, so that you have people trying to do an individual discipline kind of connection with STEM sciences that's never going to work. So if we're going to connect with the STEM sciences, which is the second bit that I'm very hopeful here in the coherence, it's got to be at a discipline group level. It's got to be resisting reductionist pressures. It's got to be a broad front advance, which I believe is still very viable and plausible. So thank you very much for listening, and I hope you